Okay, so today we are going to solve more recursion. Recursion is the most powerful tool for writing program. Okay, given a problem, most of the students generally do, they start writing some for loop, take some array, but uh, recursion is an art. If you learn how to solve using recursion and using data structure, the various call in the data structure also that can be done using recursion. So if you learn that art, you will be able to write very powerful program. Okay, so let's see some more example, very simple example you all will understand. Let's say we have some arithmetic sequence like 1 2 3 in this way up to, let's say, n, and maybe any number, any fixed number it will be given. So what we have to do, we have to take the sum of this sequence. Let's say this sequence is known as Sn equal to this. Okay, we have to compute the sum of this sequence. How we will do this? We can write a for loop and add those things that everyone do, but we'll do it the same problem with recursion. If we sum all these things using a for loop, how much time it will take? It will take order of n. We will write the same thing using recursion. Say how we can do. Let's say the sum up to the nth element is Sn. Okay, S of n. This is the sum up to the nth element. So how can we write the sum up to the nth element in terms of recursion? How to think about this? So how the last step was computed? N was added. So we can write this as S of n minus 1. This is sum up to the nth element, n minus 1th element plus the last element. Is it looking difficult? Let's draw this. Yeah, it will be more easy to. Let's say this is our 1. This is a single box. Okay, this is 1. So this is 2. We have 2 box. This is 3. We have 3 box. So what is the sum? The total area of this region, that is the sum. Now let's say in this way we have up to this. This is n minus 1. Okay, there are n minus 1 block. Okay, so this area, total area is Sn minus 1. There is n minus 1 box. So this is Sn minus 1. This total region. Okay. Now what will be the n? N will be one more box than n minus 1. So it will be, this will be n, and again the total sum will be Sn. So Sn up to this is Sn minus 1. This is the last n element. So n is added and the total sum will be n. Now whenever, so this recursion is justified with using this diagram. Now every time we are writing a recursion, we have to think about the stopping condition. When to stop this recursion? In this example, when we should stop this recursion, we can use two notation. Either there is no element, then we can stop, or you can fix the value of first element, and also you can stop. Okay, so you can write for, this is for n greater than 0 and s0 equal to, what will be the this is 0 or n equal to 0. Okay, if there is no element, then it will be 0. That can be written as a stopping condition, or you can put 1 when n equal to 1. You change this condition. Okay. That will also work. So you can solve this recursion. How you solve this recursion? Simply write a program. Okay, program name is sum of n. Okay, we have to compute the sum up to the n element. So what we will do, we have to write if n equal to 0, return 0, else return what? Sum. This is the name of the function, sum of n minus 1. Okay, it will compute. What is the complexity? What is the complexity of this program? If you solve this recursion, how many times? This will create a simple chain. Sn will call Sn minus 1, Sn minus 1 will call Sn minus 2, Sn minus 2 will call Sn minus 3, in this way. So there will be one pass linear time solution. So the complexity will be n. Okay. Now check some more problem. Let's say we have another problem. Let's take that is a small problem. We want to compute x to the power n. Okay, x to the power n, where x is large, n is large. Both x and n are very large. So in the last lecture, we have seen how to multiply two very large number. Okay, we have karatsuba algorithm for that, which compute the multiplication using a recursion, and each recursion divide the number uh, on the basis of the digit, half of the digit, then half of the digit, and then multiplication is done digit wise. Okay, that is very fast for multiplication. Now we have to compute x to the power n. How is what is the standard thinking? How we can compute? Thinking is very simple. You just multiply n every time. So you can write a recursion also. Let's say xn is the name of the function, or we can name power. This is power function. We are giving two input x and n inside power function. So what we will do, want to return the recursion when n equal to 0, what will be the power? If n equal to 0, return something to the power 0 is 1. So if n equal to 0, we have to return 1, else what we will do? Else we will return, let's say, power x n minus 1 into x. Okay, we can write into as a star. That will be okay. Should I write more clearly? X. Okay. So we can make it dot. Removing all confusion. So else we will return power of x n minus 1 into x. This is the slowest version of the recursion. What it will do, it will compute in a linear sequence. We have created the recursion, no doubt about that, but this is not very good recursion. So that is the beauty in recursive thinking. You first write a recursion, then you write a better recursion. Okay. How can we write a better recursion for this power function? Let's write it here. Fast power. We should keep short name. Let's say f underscore. Okay, f underscore power is a fast power function which will compute x to the power n. So we are passing x and n. What will be the stopping condition? Stopping condition will remain same. So we will write if n equal to 0, then we will return 1, else what to do? Else we will check two things. Okay, there are there will be two conditions. N may be even, n may be odd. Okay, so else if n% 2 equal to 0, then what we will do? What does it mean? It means n is even, n% 2 we have to write double equal to, otherwise it will be assigned. Okay, n% 2 equal to 0, it means it is even. Then what we will do? We will simply call if power x n by 2. Okay, square. How can we compute the square? You can call the multiply function of the last lecture. Okay, where we have seen how to multiply large number. Okay. Using that multiply function, you can compute this square. That will be very fast. Okay. So this is the case for uh, when n is even. Else f underscore power x n by 2. Okay, the square into x. Why? Because this n by 2, if you compute with integer, then let's say for example 7, so you will get n by 2 equal to 3, and the square will give you 3 plus 3 equal to 6. So 1x extra that is added here. Okay, so it will return the x to the power n every time. But what is the complexity here? What is the complexity here? If we solve the complexity of this recursion, that is very interesting. We will get the recursive function Tn. Let's say the complexity of a power n is Tn. Tn, what Tn is doing? Tn directly, this is a divide and conquer algorithm. Tn basically computing the recursion of size n by 2. Okay, so it will solve faster. Okay. So it is computing Tn by 2 Okay, tn by 2, and multiplication, integer multiplication, you have to add the cost of integer multiplication. So you can say integer cost of integer multiplication is n. Okay, it is calling tn by 2 and making square, so tn equal to tn by 2 plus n. It is the same, you can solve using divide and conquer, so you will get actually log n complexity. Okay, log n into o, this is not n. If there are d digit number, then it will be d. Multiplication cost is d to the power 1.6. 1.6. Okay, so you will get tn equal to tn by 2. So every time half 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 half, so in log n step you will reach the stopping condition. Means if you are starting from 16, then in this next step you will reach 8, then in the next step you will reach 4, then in the next step you will 2, and so log of 16, those many step is required, so the complexity is log n. So you can compute the power of x to the power n in log n. This is a fast recursion. So this is the beauty of recursion. Okay, you can always find some way, not always, maybe it is not clicking in your head, but there may be some better way to write recursion and we can solve the problem quicker. That's all.